All right, you guys will notice there's a pattern here, right? We're focusing on things that we've done before and elevating them. So this one, we are talking about multiplying and dividing integers as well as fractions. So what were the rules for multiplying and dividing integers? So first of all, integers, whole numbers that are either positive and negative. So you will notice there are no decimals. There are no fractions when we're talking about integers. Multiplying or dividing, one positive and one negative will result in a negative answer. And the reason I'm going to highlight this in pink is because a lot of times we think of things that are negative being, like in red. But negative answer is what you get when you have different signs. So you have different signs when we're multiplying and dividing, and that's how we get a negative. It has nothing to do with more of this, more of that. It has to do with whether or not the signs are the same or different. So here you'll notice if they are both negative, you get a positive answer. If they are both positive, you get a positive answer. So on these problems below, when the signs are different, you get a negative answer. When the signs are the same, you get a positive answer. Signs are the same, positive. Now here, you have to realize that there's actually an extra step going on. They actually did the negative 6 times the 12. The signs are different, which was negative 72. And then we multiplied by the negative 1, where the signs are the same, resulting in a positive 72. You can also look at the bottom of the notes and see where it says even number of negatives. You get a positive number. That's when the signs are the same. Odd amount of negatives, you get a negative answer. That's when your signs are different. So this problem right here has 1, 2, 3, 4, 5 negatives. The first two kind of act like a pair and come out positive. The next two act like a pair and come out positive, which means you have a remaining negative that gets to be sort of the odd man out. An odd amount of negatives would leave you with a negative answer. So odd amount of negative numbers, negative result. On to the back, where we talk about the rules for multiplying and dividing fractions that have negatives in them. First of all, we want to make sure that we are simplifying the problem. We want to solve the simplest problem possible, which means we simplify the fractions before we try to do any multiplying. What does that look like? We want to look to see if either of the numerators has anything in common with either of the denominators. And by in common, I mean divisible by the same thing. So 3 and 6 are both divisible by 3. So if I do 3 divided by 3, I get 1. And if I do 6 divided by 3, I get 2. That is simplifying the problem. I haven't done any multiplying yet. I now can say, well, what's 5 times 1? What's 2 times 4? Like we've always done in the past with multiplying fractions, but I need to take into consideration the negatives. I have a negative times a negative. The signs are the same, so my answer is going to come out positive. So I know it's a positive answer. 5 times 1 is 5. 2 times 4 is 8, and I'm done. Positive 5/8. So this one, you'll notice that the parentheses are really the thing that tells us this is multiplication and not subtraction. I've got 5/8 being multiplied by, the parentheses tell me that the 5/8 is multiplied by whatever's in it because there's nothing between the 5/8 and the parentheses. And it's a positive times a negative. The signs are different. Since the signs are different, I know that the final answer on this is going to be negative. So now I say, can I simplify the problem? Is there a numerator that has something in common with the denominator? Sure is. 2 and 8 can both be divided by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And now 5 and 3 have nothing in common. 5 times 1 is 5. 4 times 3 is 12. And we already said it was going to be negative. Now you can put the negative right in front of the fraction bar. You can also assign the negative to the numerator. We do not, as a rule, assign the negative to the denominator. It's always going to be in front of the fraction bar or in the numerator. It's actually not wrong to put it in the denominator. It is just not best practice. So you'll see me sometimes put it right in front of the fraction bar and sometimes put it up in the numerator, and they are both correct. Now here we've got the dot for multiplication. Negative 4/5 times 35/14. I can see that the signs are different. That tells me that the answer is going to be negative. And after I notice that, I start looking to see if there's any simplifying that I can do. And I notice that 5 and 35 are both divisible by 5. So I'd say 5 divided by 5 is 1, 35 divided by 5 is 7. And I actually do this out loud. I am not somebody who just starts crossing things out. I reason it logically out loud because that helps keep me organized. I also notice that I have a 4 here on the upper left numerator, and I have a 14 in the lower right denominator, and they're both even. Now, 4 doesn't go into 14, but 4 is divisible by 2, and you get 2, and 14 divided by 2, and you get 7. I could, at this point, start multiplying, but I noticed at the last second that I had a 7 over a 7. 7 divided by 7 is 1. 7 divided by 7 is 1. And now I'm actually going to have my answer in lowest terms. 2 times 1 is 2. 1 times 1 is 1. And I had only one negative, which tells me it's a negative or just -2, which is the best way to write our answer because it is in lowest terms. Now, everything else that's down here that's multiplication is going to work the same way. This one you'll notice is mixed numbers. And before we can do anything, we have to change the mixed numbers to improper fractions. There's nothing you can do with a mixed number when it comes to multiplying. So 1 1/5, how do we change that to an improper fraction? The denominator 5 times the whole number 1, 5 times 1 is 5, plus an extra 1 makes 6/5. The other 3 times 3 is 9, plus the extra 2 is 11/3. We have to remember that it is multiplication, and the second one was negative. So once I do that, once I change from a mixed number to an improper fraction, I still want to check and see, is there any simplifying, anything that I could do? And I noticed that 6 and 3 are both divisible by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2, and I can multiply the numerators. I had a negative and a positive. The signs were different, so it is -22 over 5 times 1 is 5. You can leave it improper. There's nothing wrong with an improper answer as long as it's in lowest terms. I simplified the problem, which means my answer's in lowest terms. This one has all kinds of stuff that can simplify. First one that I noticed right off the bat was the 5 and the 25. 5 divided by 5 is 1. 25 divided by 5 is 5. I also noticed that 36 and 4 are both even. So I was kind of like, ooh, I could do that. I could also do the 36 with the 28. They're both even. Maybe I start with the 4 and the 6. They're nice and low. Let's see. 4 divided by 4 is 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And, 2 and 36. What do I think? 28 and 36 are divisible by 4. 28 divided by 4 is 7. 36 divided by 4 is 9. I've simplified. I've got a 2, a 5, and a 7. I've got a 1, a 9, and a 3. You'll notice I have an odd amount of negatives, right? Only one negative out here at the front. Negative. 2 times 5 is 10, times 7 is 70. 1 times 9 is 9, times 3 is 27. And I am done. I had an odd amount of negatives, which is why my answer was negative. Now, what do we do with division? Some of you have heard it before, same, change, flip. What's actually happening is instead of dividing by -1/3, we are going to change this to multiply, and we're going to change this to the reciprocal. So 3/4 stays the same. We're going to change division to multiplication, and we're going to use the reciprocal of -1/3, which means we just have to flip it over, -3 over 1. Now it's a multiplication problem. 1 is negative, so the signs are different. 3 times 3 would be -9. 4 times 1 is 4, and I'm done with that problem. So division, some people say, remember, same, change, flip. It's also changing to multiply by the reciprocal. This one, same idea, -2/3. We would change it to multiplication, and we would use the reciprocal, -15/4. -2 is the same as -2 over 1. Divide, we would change to multiplication. Now, 4.5, I can't flip that. 4.5, I need to know that that's 9/2. So the reciprocal is going to be 2/9, right? I'm changing it from division to multiplication, and I need to change to the reciprocal. I need to flip 9/2 to 2/9. Last but not least, this is all mixed numbers. So this one's got to be -14/3. It is divided by 6 times 2 is 12 plus 1 is 13/2. That now can be switched to a multiplication problem. Negative 14 thirds stays the same. Division changes to multiplication, and we flip to get the reciprocal 2/13. All of the simplifying and multiplying stays the same once you change from division to multiplication. And you'll notice all of the directions for dividing fractions right up here at the top so that you can go back and read them over step by step if you need them. Thanks, guys.